Okay, hey, welcome to the part about radians and degrees. So we're going to learn a little bit about them. I'm going to tell you what, basically they are the same thing, just a different way of measuring. So anyway, let's learn a little bit about these. Actually, it's part of trigonometry. And trigonometry, you know the definition of it. Like tricycle. And metry just means measure. Measure of three. What has three sides? A triangle. So trigonometry just means measurement of triangles. All right. Angle. What is an angle? Well, an angle by definition is determined by rotating a ray, which is a half line. You know that one that has the end point and the other part goes on forever, about its end point. That's the definition, determined by rotating a ray or a half line about its end point. That's the definition of an angle. Initial side. What I want to talk about is this. Angle has two sides. The initial side is the starting position of the ray in an angle. In other words, the initial side is, in other words, like the starting. Initial is another way for saying starting. Starting side. Initial side is the starting position of the ray. Notice I said initial and starting, and I use starting in the definition. The starting position of the ray in an angle. And the other one is the terminal side, which would be the position of the ray after rotation, or terminal. You heard somebody's terminal, it's the end. So it's basically the end or the position of the ray after rotation in an angle. Okay, so vertex, what is the vertex? Well, it's the end point. It's basically the end point of the ray in an angle. It's kind of like, you know, and you see the vertex are corners of squares, those kind of things. That's what a vertex is. We think of it as a point. The vertex is somewhat what you would think of as a point, and hence the definition, the end point of a ray in an angle. All right? So now then, we're going to talk about standard position. You're going to come across this a lot. And the standard position is this. It's an angle that we're going to put on the coordinate system, meaning the XY plane, in which the origin or the center of it is the vertex or the end point or beginning point, and the initial side coincides with the positive x-axis. Basically what it means is this. It's going to be the end point on the origin, the point 0, 0, and the initial side is the positive x-axis, meaning if you start at 0, 0 and go straight right out on all the positive numbers on x, that's the ray. Standard position starts right there. That's going to be what we call like our 0 degrees or 0 radians, that positive x-axis, which is the point 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, and on and on. Positive angles are angles that we call generated by counterclockwise, meaning they go the opposite way of the clock. Those are going to be considered positive. And when we do these problems, you will see why the way the thing particularly works. All right? But right now you know that positive is counterclockwise. So if positive is counterclockwise, what do you think negative angles are? Ones that rotate clockwise. And if you think about it, when you're at standard position on the x-axis, if you rotate counterclockwise, the first values you have are positive. And if you generate clockwise, the first values you have are negative, because y is negative there. Coterminal angles. This is the biggie, the one that gives everybody a hard time. First off, just learn the definition. That's all you need to do today. It's at least two angles that have the same initial side and terminal sides. I mean, they have the same initial side. They start at the same place and they end at the same place. But they can go in different directions and end at the same place. How can you go in different directions and end at the same place? Well, it's very simple. Have you ever gone somewhere and somebody went one way and somebody went the other and you end up there at the same time? Same place? May not even the same time. Maybe you waited for the other one, but you waited there. That's what coterminal angles are. Ones that are at the same place. Might get there a little different. Central angle. Woohoo! Well, what do you think it is? It's an angle whose basically vertex is at the center of a circle. You probably remember that from geometry. Basically, it's any angle kind of in a circle where the vertex is at the center. Radian. Oh, Coach Stoney, what is a radian? Well, I'm so glad you asked. Let's here's something. Radian, 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 radian. Okay, whoa, Coach Stoney, man, what was that? Well, that was my attempt at a video. And that was from the song actually called, by Wall of Voodoo. It's actually called Mexican Radio. I just kind of added into it to the part of the song that has that. So you hear that tune, I'm talking about radians. And radians are, in a sense, the Greek version of degrees. Maybe that's not exactly right, but that'd be the best way to understand it. You know how we have the customary system of unit of measure, like in feet and inches? And we also have metric. Well, radian is like the metric part. And the degrees is more like the customary unit. So the radian is the measure of a central angle, theta, that's a Greek letter theta, that intercepts an arc S, meaning the arc, the edge of the circle. S is the edge of the circle, equal in length to the radius of the circle. All that says is this: a radian is defined as this. If you take the radius of the circle and were to move it along the edge of the circle, the length of the radius, that's a radian. That's a radian. And think about it. You heard of pi? Remember pi is like 3.14? There are 3.14 radians in half a circle, approximately. Okay? Now a cube. Now, here's what we know about a cube. We know there are angles between 0 and 90, but on a radian, 90 degrees is equal to pi over 2. So acute angles, instead of saying 0 and 90, now are going to use that, I'm going to call it the Greek measurement, it's just a radian measurement. It's pi over 2 instead of 90. So, what do you think obtuse is? Well, obtuse we think of as greater than 90, so it's going to be greater than pi over 2, but less than pi. It has to be greater than 90 and less than 180, so it's between pi over 2 and pi. Complementary. Now we think of complementary angles as two angles that add up to 90, but instead of 90, it's two positive angles whose sum is pi over 2. And they added a key word in here now, positive angles, because we're going to start having negative angles in a bit. So, woo, getting really complicated there. So if complementary added up to 90 or pi over 2, supplementary should be what? Two positive angles whose sum is not 180, but what? Pi. That's going to be our new definition. It's the same thing as 180. Pi is the same thing as 180, only it's called pi. So, now what is a degree? Well, how many degrees are in a circle? 360. So therefore, a degree is 1/360th of a complete circle rotating about the vertex. There's 360 degrees in a circle, so 1 degree is one of those 1/360th of a circle. Okay, that kind of makes sense. Ooh, linear speed. When you think of linear speed, you're thinking of a straight line. But it's going to be a particle moving at a constant speed along the arc of the circle, meaning it's moving along the outside of the circle, and it's found by taking the s, the length of the arc, divided by t, the time traveled. Well, that makes sense, because speed is simply, the rate of speed is distance divided by time. Well, s is our distance, the arc length, divided by t, the time. It's still speed, only we're talking about linear speed is actually going to be talking about, in a sense, on the circle, how fast we're moving around the outside of the circle. And then we have angular speed, which is going to be talking about how fast the angle is moving. The angle is going to actually move. And it's the angle in the radian measure corresponding to the arc length s, such that the central angle, theta, is divided by time. Basically, how far does the angle move over time? Because all speed is distance divided by time, but our distance now is going to be this central angle, or theta. Theta divided by time. All right.